Hello friends, in this video I'd like to solve the following problem from the Swedish Mathematical Competition, final round 1993, problem number 1. An integer n has the property that the sums of the digits of n and 3n are the same. Prove that n is divisible by 9. So this problem is pretty easy. My hint, use the following lemma and try to prove the following lemma. So denoting s of n to be the sum of digits of a natural number n in decimal system, then the following congruence is true. The sum of digits of n, s of n, is congruent to n modulo 9. So give this problem a try and I will see you in a minute. Okay, so let's start with proving our lemma. Proof of lemma. Proof of our lemma is very simple. We know that in decimal system, every number can be written as a sum, which goes from 0 to some L, consecutive digits times consecutive powers of 10. Okay. And that means that s of n equals just the digits themselves. And now let's look. N is congruent to the following sum, and 10 is congruent to 1. So it's congruent to sum from k equals 0 to L, dk, and that is just s of n. Of course, we are talking modulo 9. And that closes the proof of our lemma. Okay, and now for our proof. By assumption, let's do it in the following way. S of 3 times n is congruent on one side to 3n by the lemma, while by assumption s of 3n equals s of n. It's by assumption. And this is again congruent to n by our lemma, modulo 9. So taking these congruences together and subtracting them, that means that 2n is congruent to 0 modulo 9, and 2 is co-prime to 9, so we can safely divide by 2 to say that n is congruent to 0 modulo 9, i.e. is the same as saying that 9 divides n. And that closes our proof. Thank you for watching and I will see you next time. Goodbye.